By the way, I'm Russell Huey. I'm from here at UCSF. I'm glad everybody could make it and be here. And yeah, I'm gonna start off by kind of walking you through common data elements a little bit. There's a few of you who were here all morning, and we talked somewhat exhaustively about common data elements. But in general, we're just talking about sort of a framework where we are kind of aligning to a shared language so that we can all be able to communicate with each other better, and hopefully our data are not lost in translation here. So um, just to kind of get a framework going here, I want to start with sort of a very simple experiment. We're going to work through sort of some exercises that are kind of based around something very simple. If you're working in a TBI lab, let's say you have a question, you want to know how TBI may affect memory, and you just have a very simple experiment where you may give a sham surgery to an animal or a TBI a surgery, and then you're going to look at something like a behavioral test of spatial memory. Let's say a Barnes maze, for instance, right? So if we're just imagining, okay, we're getting ready to set out and design our experiment here. Imagine that we at some point are going to want to share the data from this experiment with others. There's a lot of reasons why we might want to share our data. First of all, the NIH might be asking us politely but firmly that you do so. Um, you may also hopefully be, as we move into the future here a little bit, collaborate more with other labs. Also, you may be collaborating with other people within your own lab. I certainly know from my time in training in grad school that people collect their data everyone does it their own special little way, right? And hopefully it all comes together and you write a paper and the paper gets out, and maybe that spreadsheet or that tab in that other guy's spreadsheet is lost somewhere, and sometime in the future someone may come back and actually want to look at those data and try to use them again. And the real question is that going to be possible at all? Are you even going to be able to understand maybe what you did, or whether or not you wrote some of the data down on napkins? Not that I ever did that. So imagine too, 10 years down the road, someone would like to revisit these experiments. Is there any way that anyone's going to know what you did, or even if you'll be able to know what you did? So what do other people actually need to know in order to be able to make sure that these data are useful? All this hard work that you've put in, I think really one of the key take homes in all of this open data sharing and common data elements is that we want you to be getting the most out of all this hard work. You spend a ton of time and effort and money to collect these data. The data themselves are a work product, and they should be treated as such. And so what do other people need to know? How do we ensure that your data is actually going to be reusable, useful to the community? So what we really need is to be able to sort of speak a common language across the field. And this is where things like common data elements come in. Can you see this little spreadsheet? Okay. If you can look at this, well, first of all, this might look a little bit familiar to some people. This may be the way sometimes people, I did just make this up, but I didn't have to try that hard to make this up. It has a certain structure, a certain format in and of itself, but you may understand this. If you were to put this down and you say, okay, this is where I put my shams and here's where I put my injured animals. And oh yeah, by the way, number 4, I need to double check that one. That might have been mislabeled. So I'll put a little note there. And yeah, okay, here's this was my Barnes maze, but this is the real final one, but I needed to redo it and then I fixed it. And so I'm going to label it that. And I'll remember that's what that was supposed to be. But who else is ever going to be able to look at that spreadsheet, or even want to, and make any sense of all that work you did? So can other labs work with your data? Can other people in your own lab work with your data? Right? This is what we're really trying to get at. So here's another example here. This is actually one that we're going to be working with here in just a minute, if folks are interested in working along here. This is a much better organized spreadsheet, and this may actually be very similar to the way that a lot of people are actually collecting their data. It makes sense. It has some sort of internal logic to it. But would it be not only machine readable, we'll get to that, but would other people be able to know exactly what each thing means here? this says latency. This is very small at the top. This says latency, and we have animal and group and treatment, and then we have trials 1 through 8, and then we have these values. And we could probably figure out, okay, so there's 8 trials, and these values represent latency. This maybe it's a Barnes maze type experiment, but we really don't know for sure. And especially, like I said, 10 years from now, somebody might look at this and have no idea what's going on. So here's just kind of a thought experiment. And if people, I'm more than happy if people would like to shout out or raise their hands or whatever, but what do you think would be some variables that you would want to include in order for other people to maybe someday find this data useful? Anything. Time, perfect, right? Time point after injury. So in this example, I'm sorry, Gene, we're tearing your. Sorry, not to spoiler alert. No, this is perfect. This is exactly why they're doing it. And Gene is extremely brave to volunteer his data and say, yes, let's look at this and understand. Like, oh yeah, this makes sense to me. But absolutely, time point. We don't really know if, okay, there was a TBI, but when did it occur? When are each of these actual measures taking place after the injury? Other things that could be useful. I said TBI. TBI. Exactly. No, you're exactly right. I'm just playing with it. That's exactly right. Right. Even you double click on the concept of TBI and you look even or even heck, even CCI. Well, okay, what does that mean? How did you do it? Exactly. Species. Oh yeah. Even if it's an animal, yeah, a strain. Okay, see, this is great. Like this is sort of the idea. Now, once we start thinking about this a little bit, how many animals per arm? Okay, exactly. So this is all stuff that we need to be thinking about when we're considering that our data. You know this back in the lab, but when we're starting to think about sharing our data and making sure that our data are useful to the community and that you can get the most out of your data. So again, yes, we would add every one of these things would be great. Anything else folks think would be useful? Age, sure. Exactly. Age when the experiment started. If we don't know time point, these could be months after. Sure. Right. Exactly. And actually, that's a great point too. Maybe a free text notes box that says, hey, here's what went wrong.
That ton of time, but then you also mentioned time point, but then there's this other thing, trial. What is that?
Right. Exactly. So we don't know. There's, yeah. And that's a great point. That's a great point too. Time within time with it. It's a flat circle, but it's, but that's a fantastic point too, because within, and we'll actually see this in a minute, even within, let's say, days after injury, if you have a number of trials or some kind of repetition, some sort of replication, technical replication, those also have time points that go with it too. And what does that mean to have a time point 1 and a time point 2? And is that consistent across days, things like that?
Say, I predict biomarker X will peak at this time, and that's when they'll set their observation at time points. And there are other people in the field that will set it differently, and you end up with a whole bunch of heterogeneous results because of that.
Exactly. And so if we don't know the exact sort of the granular, here's how far after the injury itself, then there's really no way to align those, right? And this is how obviously we get into situations where someone says, I found this great effect. I found it too. And you try to replicate or try to harmonize even. And they're completely, two separate things. So I think this is great. I think people are kind of thinking in the right direction. And in fact, I think this is from Monique. Going back and actually looking at the preclinical TBI observations that are actually missing out there in the data. We do a pretty good job of making sure we're collecting things like sex and species. These black lines are actually showing that the data were included, but that what these others were missing. What you see is, as we get moving to the right, more and more missingness. Folks not reporting the strain exactly. Things like weight. Okay, obviously this means a lot. Their age in weeks, the TBI model, and even when we talk about the model, right? What type of device or who manufactures the device? Very few people are actually putting that into their data sets. And we have all of this information. We just need to make sure that we're including it and making sure that everyone is able to see these things so that we can go forward and be transparent about what we're doing. So just a couple of, these are great answers, and these are great sort of topics to think about. So basically, as we were just discussing, we need to know things like species. These are just sort of some broad overall domains that are really important to make sure that we're including in our actual data sets. What are our species, our experimental groups? What's our actual injury model, and the specifics of that injury model? What are we actually doing? And we've talked a bit, we'll talk more in the future too about things like protocols.io, where you can get even further into the details and publish your protocols themselves. And then outcome measures, making sure that it's very clear what your outcome measure is, what it is you're measuring, and when. So this is where we need common data elements.